So we know a couple of pieces of information here. It states that the point y lies on L2, and then given that the vector y to a is perpendicular to the line L1 where point A lies on L1 with this position vector, we need to calculate the distance YA. Okay, so that's fine. So before we do this actually encompasses a few things from previously. We need to see how the diagram looks like. And well, it actually looks a bit like this. You see? So I've actually gone ahead and drawn it. So we've got the line L2 crossing here, and if we recall, L1 and L2 intersect at point X. We found this in the earlier statement. The lines L1 and L2 intersect at X. We also calculate the acute angle, find the size of the acute angle between L1 and L2, which was 74.4. And that is here. We also calculate the line AX, which is here, 9 root 3. So looking at this carefully, we got a clean right angled triangle to work with. And what else can we see here? So we can actually use a few things. We could use, in this case, SOHCAHTOA to work this out. Or we could use a sine rule to figure out the next angle. But yeah, let's go ahead and find this distance, which is, let's just label this side x. Okay, for convenience sake. So from here you can picture a right angle triangle. So we have a nice simple one with length 9 root 3, length x here, and the opposite angle would be 74.4 degrees. Okay, so good old trick. Now, to do this, we just have to consider labeling some sides. So because this is the opposite, we can call this side O. So let me just write O here. And we can call this side the adjacent. So, oops, let me get my pen. Adjacent. And lastly, guys, so now we got this, we just need to use the relationship of SOHCAHTOA. And for those of you guys who don't know, SOHCAHTOA is the trig relationship between sine, cos, and tan, where O is opposite, A is adjacent, and H is the hypotenuse. Now, which one do we use? The way this works, you look at your right angle triangle and ask yourself, well, what's involved? Well, we can see that the O is involved in the A. And the only thing that's O and A is TOA. So this implies that tan of the angle, 74.4 degrees. Wait, what was the correct angle? 74.37, I think that's more accurate. But anyway, same thing. Must equal opposite over the adjacent. And opposite over the adjacent is actually x over a. So let me write down x over 9 root 3. And therefore, to find x, well, you just multiply 9 root 3. So it'd be 9 root 3 times tan 74 well, let's write the original one, 37 degrees. And that's it, guys. You just worked out and then you have your length. And if you did work out, let's see what we get. So, oh yeah, make sure your calculator is in degrees mode, yeah? So 9 root 3 times, I should have done this before, 74.37. And I got 55.7, 7 what is it, meters? Kilometers? I don't know. So length for 55.7. So right here, the x equals 55.7. Let's say meters, I'm not sure what, or units.